Welcome viewers. Here is another examples under our topic surds. In our previous lesson, I explained how to reduce surd and I gave the definition of surds. Now we want to consider the rules of surd. How do we work with operations? How do we work with surds regarding our basic operations? How do we add them together? How do we subtract? How do we multiply or divide? So now we are starting with multiplication rules. So the multiplication rules of surd says that you multiply the value you have outside the root with the value outside the root. Then the value you have inside the root with another value inside the root. So that is, when you have a root b multiplied by c root d, your a and b can be any value, can be any integer. Your a and b can be any integer. Sorry, a can be, all these values can be any integer generally. So now, when you want to multiply these two surds together, you are multiplying the value outside the root with the one outside the root. Here now, a is outside the root here, c is outside the root, outside the square root. Now you multiply them together. Also, the value you have inside the root will also be multiplied together. Now, going with this rule now, it means we are going to have a multiplied by c. Then you have the square root of the value in the root, b multiplied by d. And this is how the rules works. So you multiply the value you have outside the root with the one outside. You multiply the one inside the root with the what? The one inside. So, and I can just summarize this as a insider for what? Insider. Then outsider for outsider. That is the value in the root with the one inside and the one with the outside with the one what? Outside. Now let's work with these examples now. Example 1. We have 3 square root of 5 multiplied by 2 square root of 6. Let's multiply these two together. 3 times 2, Abi? Yes, we are multiplying 3 and 2 together because these 3 and 2, they are outside the root. So now you have a 3 multiplied by 2. Now, the value you have in the root will also be multiplied together. So I keep this now. That is 5 multiplied by 6. 3 times 2, that is 6. 5 times 6, that is 30. So meaning this equals to 6 root 30. Now, 30 is a big value. Is there any perfect square that can divide 30? If you check, among those perfect square we have, so none of this, no perfect square can divide 30. So because of that, your result is valid as this. So this is your result. So that's the final answer. Now in the second example, we have 6 square root of 10 multiplied by 7 square root of 5. Now here also, we are using the multiplication rules. Multiplication rule says that multiply the value outside the root with the one outside, multiply the one inside with the one inside. Again, we move. Now that is 6 multiplied by 7, and that is 42. Now, 10 multiplied by 5, and that is what? 50. Now, once you get to this point, you check the value you have inside the root. Can we reduce this? Yes, we can reduce it. Is there any perfect square that can divide? The answer is yes. Okay, which perfect square can divide 50? And that is 25. That's 25. So you have 42 square root of this 50 will now be 25 multiplied by 2. So 25 times 2 is 50. Now what's square root of 25? So we still have 42 outside. Now multiply by square root of 25 is 5. Then root, you cannot find square root of 2, so that 2 will still remain inside the root. Now 45 times 2, and that is just 210 square root of 2. And that's just the end of this example. Now let's consider, so this is all about product rule. Now let's consider the division rule. How do we divide two surds? Now you can see these examples. We have the two examples we have here. It included in these examples we have both multiplication and division. So you can, in board maths, both division rules and multiplication rules, they can be interchanged. You can divide before multiplication, you can multiply before division. So any of the two can be done first. Likewise, addition and subtraction. So you can interchange, you can do addition before subtraction. You can also do subtraction before addition. Now let's consider this example. So now, as I said, we can decide to divide first or we multiply first. What is division rules is saying? Division rules is saying the same thing what multiplication says. Multiplication rule says you divide what you have inside the root with what you have inside the root. You also multiply what you have inside the root with what you have inside the root. Now, and if that should be the case, then it means we can divide directly here. So now this value is outside the root. 3 is outside the root. And since they are linked with multiplication and division, so 3 will cancel out 3 here. 2 here 1. 2 here will be 2. Now, let's consider what you have inside the root. Now, for what you have outside now, here you have 2. Square root. Now, square root of 2 here can also divide square root of 6 here because both 2 and 6 are inside the root. So 2 in 6. 2 here is 1. 2 in 6, that is 3. Multiply by, here we have just square root of 15 inside the root, square root of 5. So 5 can divide 15. 5 here 1, 5 in 15 is 3. So you have square root of 3. There's no any other value again. So we can now multiply. So you can use several ways to solve this question. Somebody may decide to just go by multiply outside with the value outside with value outside, the value inside with value inside first before you start your division, and you can do otherwise. Now, here we have 2 outside the root. Now, the value inside the root can be multiplied by the value inside the root. Or why do you have 2 here? The coefficient here is 1. So there is 1 outside, but you don't need to write. Just like in math, you don't write 1x. Rather, you just write your x. You don't need to write 1x. Once you write x, we understand that you mean just x. Now, here also now, 2 multiplied by 1 is 2. So that's why 1 there is 1 here. So 2 times 1 is 2. Now multiply the value inside the root with the value inside the root. Now, let's do that together again. We have square root of 3 times 3. Now 2 is outside. Square root of 9 is what? 3. Now 2 times 3, that is 6. The first example, we try to divide even before we try to multiply. We try to divide before we start multiplying. Now let's consider this example. Let's try to multiply first before we divide. Since I said you can decide to multiply first, or if you wish, you can start with a division. Now let's start with multiplication now. So now we have 20 multiplied by 6 multiplied by 3, because the value outside is multiplying the value outside. 20 times 6 times 3. 6 times 3, that is 18. 18 multiplied by 20, that is 360. That's 360. Now let's multiply the value here also. 14 multiplied by 35 multiplied by 2. This is also possible. So when you say 7 times 7, that is 49. 49 times 20, that is 980. I just multiply my own way, so you can also do in your own way too. So what I really did here, this is 7 times 5. So 5 here multiplied by this, that is 10. I have 10. I have 7 here. 14 times 7 is 98. 98 multiplied by, and that's how I got my 980. So now divided by 28 multiplied by 10, that is 280. 280. Square root of 3 multiplied by 10, that is 30. Now, in this second example, we multiply before we divide. Now we want to divide. You know the rules of surds says you divide the value inside the root with the value inside the root. The one outside with the one outside. Now 10 goes in 360, that is 36. 10 goes here, that is 28. Another value that can divide this is 4. How many 4 goes here? That is 7. 4 here, that is 9. Now we have 9 and 7 outside. We cannot reduce what you have outside further again. Now, how many 10 goes in 30? That is 3. 10 goes here, that is 98. So 3 cannot divide square root of 98. 3 cannot divide 98 inside the root. So now we have 9 outside the root. 9 outside the root. Then what you have inside the root will now be 98 divided by 7 outside, square root of 3 inside the root. Now before we move further again, this square root of 98 can be reduced. So because there is a perfect square that can divide 98, which is 49. So now we express this 9 is outside already. Square root of 98 will now be 49 times 2 divided by 7 square root of 3. Then we move further again. Square root of 49 is 7. So now you have 9 times 7 square root of 2, because you can't find square root of this, so it remains. You can't get whole number for square root of 2, so that square root of 2 remain like that, divided by 7 square root of 3. Now 7 outside there can divide 7 outside here by division rule of a sort. Now what is left is 9 square root of 2 divided by square root of 3. Now you cannot leave this like this, but watch out for my video on rationalization of sort, on how to go about this. So you cannot leave your result like this. So because our lesson is not going to that stage at this level, so I will need to stop here for division of